Okay, let's get started with the center mass of rigid body, now with a non-uniform density. So we have a bar here. This bar has been discussed before, but it had uniform density. Now it has a non-uniform density. So here the density changes with position. Alright, so we know that the bar is between minus 0.25, 0.25, and this is a 0.50 meter long bar. So minus 0.25, here's a 0, here's plus 0.25. Alright, so what do we do now? Now with the bar, what I like to do is to just pick a random section here, this section. I'd like to pick it above 0, so that's just my preference. And this random section has certain amount of mass. Let's call it delta m. So this is a finite section, delta m. And it also has a finite width. So let's call the width delta x. Here's delta x. Alright, so how much mass does delta m have? Well, approximately the width times the density. This density may be at the center, maybe at the center of this piece. So it's an approximate because you know density here changes across this whole piece. So if you just take one density from the center, it's not a good representation of the whole density, but it is an approximate, right? But if you take a limit where delta x approaches 0, then this becomes a better approximation. So this delta m will be going from this delta x to a dx. So this becomes a dm, infinitesimally small mass, and it will be lambda and the dx instead of the delta x. See, all the delta variables, delta here, they become d's because we take this limit. Okay, so this gives us that equation that transforms the mass into a position or coordinate, so we can later integrate with. Alright, so let's recall what integrals we're supposed to do. X center mass is equal to two integrals. The top is x dm, the bottom is just dm, or the dm's integration is also the total mass of the system. Okay. Alright, so that's center mass. So let's calculate one integral at a time. Let's do the dm. So the integration of dm. Now we turn dm into the lambda dx. So lambda dx. And that becomes, substituting lambda's expression for lambda, 0.21 plus 0.9x plus 1.5 x squared dx. And we'll also put the minus 0.25 and 0.25 here. Specify the size or extent of the bar. Okay, so now we should be able to separate this into three separate integrations. The first one is the integral of 0.21 dx. That gives you 0.21x. And next one is the integral of 0.9x. That should give you 0.9x squared over 2. And then also an integral of 1.5 x squared dx. That should give you 1.5 x cubed over 3. I'm skipping the limits just to save some time. So the next line we have the result of each integral, 0.21x plus 0.9 over 2 x squared plus 1.5 x cubed over 3. And we evaluate this expression between minus 0.25 and plus 0.25. Okay, to evaluate it, we plug in the value into the expression, plug in this value into the expression, and we'll subtract the 2. Okay, so 0.21 times 0.25 plus 0.9 over 2, 0.25 squared plus 1.5 over 3, 0.25 cubed. Subtracting when you plug in the negative, so then it's negative 0.21 times 0.25. Okay, and this one doesn't have the negative because you're squaring the negative quantity into a positive. So 0.25 squared, and now you have a negative again because you cube the negative. The cube of negative is still a negative. So now we just move on over here, minus 1.5 over 3.25 cubed. Okay, so as you can see, this one has a positive sign, this one has a negative, so they are subtracted away. And the other terms, they double up, right? This one doubles up with that because of 2 negative. The same thing happened for that other one. So there's a 2.21 times 0.25 plus 1.5 over 3.25 cubed. Okay, so you can pull out your calculator and get your answer. And the number is 0.121. 0.121. Okay, so let's move on to the next integral. The next integral is integration of x dm. This turns into x. The dm is lambda dx. And then x 0.21 plus 0.9x plus 1.5 x squared dx. So the same limits, minus 0.25, 0.25. And we're separating them into 3 separate integrals, just like what we did here before. So 0.21x dx and 0.9x squared dx, 1.5 x cubed dx. So all the terms look similar to the ones we had before, but they all have power of x, additional power of x, such as this one compared to this one here, right? So let's do the integration. 0.21 over 2 x squared plus 0.9 over 3 x cubed plus 1.5 over 4 x to the 4th power minus 0.25 plus 0.25. Then we plug in the numbers, right? So we're familiar with this routine. And subtracting with the negatives. So negative 0.25 squared, I'll use positive 0.25 squared. And here cubed with a negative. Here's 4th power, again becomes a positive. And then we realize these two terms subtract away, and these two terms subtract away because of negative in front, and these two will double up. So the answer of this is twice 0.9 over 3.25 cubed. So you can pause the video and calculate this with your calculator. So the answer is 0.00974. I like to keep 3 digits because I need to divide the two terms. Okay, so now the final answer, center mass, is the division between these two, so 0.00974 divided by 0.121. And that answer is roughly 0.078 meters. Thank you.